So normally I do a different style of video. I usually present it to you with a much more edited and more focused way, but I'm going to try something different, and I'm going to try and do a past paper. This is the Specimen past paper for statistics, the GCSE Statistics course for EdXL. It's the higher paper 1, and I'm basically just going to try and answer it as if I was a student taking the exam. Now it's been a whole year since I last took GCSE Statistics, so do forgive me if I make mistakes, and please do give me feedback on how exactly I do, because yeah, I don't really do this often, and this is much more different from my edited approach, where yeah, I filter out a lot of my thoughts. So I will be having a mark scheme with me as I do the questions to make sure I'm not giving any false information, but I'm going to try and give my initial thought and then cross-examine it and reference with the mark scheme to make sure I'm correct. And yeah, it will influence how I answer the questions, but I'm going to try and give an insight into how I would approach the questions, so hopefully it will still be some use to you. And if you need it, here are the formula that you're given. Now, the formula that you need to remember, there is a list. I'll try and put it in the description if I have time. It's a longer one than this, but again, most of them you can derive them, and it's not too hard to memorize. More about intuition, and yeah. So let's do question 1. In the first question, we're told that the Venn diagram shows us information about 20 films shown in the UK in 2015. A is the event that the film was produced in the UK, and B is the event that the film made more than £40 million. The numbers in the Venn diagram indicate the number of films. We're told to explain fully what the number 3 represents in the Venn diagram. So 3 is in this section here, this little, it's literally called the intersection point. And the intersection point, basically, if you don't know your Venn diagram notation, I'd suggest revising it, but it's A intersects B, and that's the intersection point. Now, this means basically A and B. So A is the event that the film was produced in the UK, and B is the event that the film made more than £40 million. So if we're looking at the intersection of A and B, then we can see that this means it was produced in the UK and it made more than £40 million. So I'll write this. We're told to find the probability of B. Now, I don't want to overcomplicate this, but we need to look at the context because that will help us understand it. B is the event that the film made more than £40 million. Well, you're just asking the probability of B is that out of all the 20 films that were made, because it says 20 up here, how many are in B? Or what is the probability of B, which is how many of them were made with the set B in mind, which is the event that they made more than £40 million. Well, you can see that this is 3 plus 2. So it's going to be 5 over 20. That's going to be our answer here. For part C, the probability of B, and then this line, A. This firstly, we can write this as, this means given. Now, you read it as B given A, and this means that given this happened in A, what's the probability that will happen in B? Now, there are some formulas you need to know, however, it's not really necessary and you can derive them on your own, but I'll just write them out here. So, the probability that B given A is equal to the probability of the intersection of A and B over the probability A. And you can kind of visualize this in a graph. You're going to find the probability of A, which is everything in this part here, and then you're going to find everything within that part, which is also in B. So this part here. What you end up with is, if you just find the intersection of A and B, and we've already got the intersection is 3, we just need to find the probability of this. So the probability of intersecting A and B is 3, and the total number is again 20, as we've seen from the top. So we'd have 3 over 20. and then we'd have to divide it by the probability of it happening in A. The probability of A happening is 5 plus 3 out of 20, so 8 over 20. If you just type this into your calculator, there's no need for you to do this in your head, because in the exam you're going to be under high pressure and you're just going to make mistakes, so it just gives you 3 over A, which would be our answer. Now how would you be able to find this out? Using some intuition. So it reads B given A. Now it's kind of self-explanatory. Once you get it, it just clicks. So given A means that it has to be in this circle A, and the probability that happens in A and B, well, it's only this one. Only 3 happens within A and B, which is the intersection, and only 8 happen in just A. And that basically gives you your 3 out of the 3 plus 5, which is 8. However, this is a more soundproof method. It's more likely to get you the marks because it's showing you're using the formulas. Using your answers to part B and part C, explain whether or not A and B are independent events. Now this is going to use some pre-existing knowledge. You've got to know this or you're not going to be able to really answer this question. So the probability that B given A, as we know, is 5 or 3 over 8. Now, if they're independent, and if they were, this means that A does not affect B, and B does not affect A. That's as simple as it gets. Now, if that was true, the probability of B should just be equal to the probability of B given A, and the probability of B is 5 over 20. Now you're saying that if they're independent, A doesn't really affect it at all. A is kind of just, well, it's just redundant here. So if they were equal to each other, then we could say that the probability of B given A, as is equal to the probability of B, then they must be independent because A clearly has no effect here. But if you look at it, 3 over 8 is not equal to 5 over 20. In fact, this means that they can't be independent. And this is basically the reasoning you have to give, is that the probability of B given A is not equal to the probability of B. So what you'd write is that 3 over 8 is not equal to 5 over 20, so they are not independent. This was kind of difficult, well, mostly part D. However, if you found the first couple of parts kind of hard, I'd recommend that you'd revise Venn diagrams and probabilities because, well, it's not really high in marks, it's still an important topic, and obviously if you don't get it with the exams this close, you should probably be revising this. Now, that's the end of this question, for question 1. We'll move on to question 2 now. There are 11,727 students at a university. Their nationality is classified as either UK, EU, or international. The table shows information about the nationality of these students. And here's the table. The manager of a bookshop wants to carry out a survey into the books read by students at this university. She is going to take a sample of 600 of these students. The manager plans to sample 200 UK students, 200 EU students, and 200 international students. Write down the name of this method of sampling. Now, instantly, without even looking, 2 things come to my mind because I'm seeing the exact same number. Now, it could be stratified sampling, or it could be quota. But here's a key clarification. Stratified sampling is when you do it by proportion. So for example here there's much more UK students than international students because, well, you can clearly see there's roughly around 8 times more. However, you're going to use the same number of students for each. That's clearly not proportional, whereas quota is where you use the fixed quota. You use a fixed number of students or whatever you want to test per group. So this is going to be quota sampling. Now give a reason why this method might not be appropriate. Well, just like I said, if you're in the UK and there's only 200 of you being selected out of all of your fellow students, and you see that 200 are also being selected out of EU or international, you're going to be quite annoyed if you wanted to go to the bookshop because you've got less chance of being in, and therefore it's not representative. Looking at the mark scheme, you could also put that it's not random or it's possibly biased. For part C, a shop assistant suggests that it would be better to select a sample of 600 students and then stratify by nationality. Work out how many EU students there should be in this sample. I'm just going to state the formula. You don't have to, but it just helps me when I remember it. So the strata over the population, or the total, multiplied by the sample size. And this should give us the number of EU students that should be in the sample. So if we look at the EU students, that's this one here, we get 979. That's our strata. And then the total, the question says here and says here that it's 11,727. And then we use our sample size, which is given by the question again, which is 600. So we need to put this into the calculator. Now feel free to just put this in. So I've typed that into the calculator, and what I've got is 50.08 and so on. And since we're talking about students, i.e. whole numbers, we're going to just round it to the nearest integer, so 50 students should be in our sample. Part D says that 3 students, Amy, Beth and Carlos, bought the same 8 books from the bookshop. The manager asked Amy, Beth and Carlos to rank these 8 books in order of how much they enjoyed them, increasing order, sorry. The manager calculated the Spearman's rank correlation coefficient for the ranks given by Amy and Beth. She got a result of 1.2. Explain how you know that this result is not correct. If you do Spearman's rank calculations, and you would have to do them, you will know that you will never get an answer between -1 and 1. Because simply Spearman's rank measures how strong or weak rank correlation is. So if you see a value outside 1.2, this can't be correct. Just like you know that probability cannot be outside the range of 0 and 1, Spearman's rank is similar in the fact that it cannot be outside -1 and 1. And you can see that 1.2 is greater than 1. So the result cannot be correct. In the exam, I'd possibly make this a bit more worded, and I'll say that Spearman's rank correlation coefficient can only take these values, -1 and 1, and then I'd show that 1.2 is greater than 1. However, this should be sufficient. The manager also calculated the Spearman's rank correlation coefficient for the ranks given by Beth and Carlos. She got a result of 0.74. What type of correlation is shown by this result? Since the whole thing seems to be 2 marks, I'll just write positive, but sometimes you might need to be more specific and give, well, an adjective, either strong, weak, moderate. Interpret this result. Well, a positive correlation can be kind of seen like this, so like that, and it basically suggests that as the rank of one goes up, the rank of the other goes up. So they basically have similar ranks, and they're basically ranking books here, if I'm not wrong, and they're ranking their books in increase in order. So if they're ranking books kind of similarly, we could say that Beth and Carlos agree, and then probably reasonably, with each other. And that is the end of question 2, and that is the end of this video. Now, I probably wasn't the best, and I probably made a lot of mistakes, and I'll have to go back and check. But please do give me feedback, and if you did enjoy this, do tell me, because I'm just trying a different style of video. And if you want more of this before the exams, do let me know in the comments section below. Anyways, thank you for watching, and I'll see you in the next one.